Good day and welcome. I'm Mr. Simons. Here we're looking at grade 11 analytical geometry questions tested in grade 12 exams, and this is a rhombus related exam question, right? So in November 2012, ABC is a rhombus with A being minus 3 and 8, C being 5 and negative 4. The diagonals of ABC, D bisect each other, they're at M. The point E, 6 and 1 lies on BC. So 1, they want us to calculate the coordinates of M. So if they're bisecting that, there's a midpoint. Then they want the gradient of BC. Take note, they didn't give me the coordinates of B. But to get gradient BC, I should know that B, E, and C are collinear, so I can use E and C. Determine the equation of the line AD. So you want the equation of the line AD. This is a rhombus, so AD is parallel to BC, so I'm going to get the gradient for AD from BC, then substitute A in. And then they want us to determine the size of theta. And there I should remember that all four sides of a rhombus are equal, so AB equal BC, so therefore theta there and theta here. Right, but let's look at the problem itself, just to give you a guideline of what we're looking at. You can pause here and attempt to answer it yourself and then go check at the answers, or you can just follow me as I explain. Please feel free to comment, or if you feel there's anything I can do to make the lesson better. So 5.1, calculate the coordinates of M. So diagonals bisect in a rhombus, so M is a midpoint. So A is minus 3 and 8, C is 5 and negative 4. So for midpoint of AC, say x1 plus x2 divided by 2, y1 plus y2 divided by 2. So minus 3 plus 5 divided by 2, 8 minus 4 divided by 2, 5 minus 3 gives me 2, 2 divided by 2 gives me 1. 8 minus 4 gives me 4, 4 divided by 2 gives me 2. So the coordinates of that M there, my x value is 1, my y value is 2. Alright? And say 2 marks, 1 mark for substitution, 1 mark for the answer, or sometimes 1 mark for x and 1 mark for y. So hope you follow. Let's look. 5.2. Say calculate the gradient of BC. Alright, so as I said, gradient BC equal gradient EC. They are collinear points, meaning they all appear on the same straight line. So if I use E, which is 6 and 1, and C, which is 5 and negative 4, gradient EC equal y2 minus y1, x2 minus x1. There 1 minus minus 4, 6 minus 5. So 1 minus minus 4 gives me 5. 6 minus 1 is 1, 5 divided by 1 gives me 5. So gradient EC, which is my gradient BC, equals 5. So hope you follow. So 1 mark for substitution, 1 mark for answer. See, they have color coordinated. Make sure you substitute the proper x's and y values in the proper places, please. Right, we're tired of marking where you'll have the proper formula, but you go put y in the place of x, or you go put the x and y on the same line, then you go write 5 minus 4 there instead of separating them. Right? So look at 5.3. Determine the equation of line AD in the form. So number 1, AD is parallel to BC. No? They're parallel because it's opposite sides of a rhombus. They are parallel. So my gradient AD equal my gradient BC, which we found as 5. So in the equation y equal mx plus c, m now equal 5. So we have y equal 5x plus c. Right? On AD, I only have the point A, which is minus 3 and 8. So that's the only point I can use on AD. So that states that my y value is 8 when my x value is negative 3. 5 times negative 3 gives me 15, or negative 15. If I take it over, it becomes positive 15. 15 plus 8 gives me 23. So C equal 23, therefore my equation reads y equal 5x plus 23. Right, so hope you follow. So number one, I had to know opposite sides of a rhombus are parallel and equal. Therefore, two lines that are parallel share the same gradient. And then, to get the coordinates of C, my cutting value, meaning where it makes contact with the y-axis. So we continue up, that will make contact there on the top by 23. Alright, so we can only use the point A minus 3 and 8. So look at point 4. Alright, now for 5.4, determine the size of theta. That is BAC. Show all calculations. So number one, we should remember given to us ABCD is a rhombus. So therefore AB there equal BC equal CD equal AD. But AB equal BC, therefore BCA, BCA, this angle that's formed there, right, equal theta. Remember, equal sides, equal angles, right? So that there is equal to theta. BCA would equal ARS minus RSC. So when I say ARS, this exterior angle of a triangle there, equal the sum of the two opposite interior angles. So there, R or RSC, RSC. So that angle there plus this angle must equal the exterior angle of the triangle. Right? So to get ARS, we're going to use gradient AC. To get BST, that angle on the outside, remember they're vertically opposite. So when I get this one, I'm automatically getting the angle on the inside. So BST equal gradient BC. So for ARS, I'm going to use the coordinates of A and C. So therefore 8 minus 4 minus 3 minus 5. That gives me 12 over negative 8. And there 4 goes in 12. 3 times 4 goes in 8, 2 times. So gradient ARS or AC equal negative 3 over 2. For gradient BC we calculated was 5. From there, if I say shift tan, negative 3 over 2, my calculator will give me negative 56,3099 degrees. Because it's negative, I'm going to say 180 minus that, which then gives me 123,69 degrees. There, shift tan 5, BST equal 78,69 degrees. Alright, so theta then equals my biggest exterior angle minus the interior angle. No? So 123,69 minus 78,69, which then gives me 45. So as I explained in the grade 11 work on the angle of inclination, if you want to, Simon's Math 11, go look at inclination of a line, the lesson. We always test the exterior angle of a triangle equal the sum of the two opposite interior angles. This one that I found here, 78,69, is automatically the angle on the inside because they are vertically opposite. So hope you follow. Alright, let's go look at 5.5.